back to this chart, which I've shown many times, of all the connective tissues and their origin. And I have, you notice, cross these out because we're done with them. And I wanted to just step back and remind you of where we're at. We've looked at in previous videos the 3 loose connective tissues and the 3 dense connective tissues. Now we need to move to the supporting connective tissue types. These are the ones that really give you, structure, so you're not just a blob of jelly on the floor. We are not going to cover bone right now. I'm going to talk about that with chapter 6, which is coming up pretty soon. And then blood, we're not going to talk about right now either. That's coming much later, like unit 4. So the only connective tissues we have left right now, Ray, are the 3 types of cartilage that I'll go through. Oh, sorry. Okay, what is the function of cartilage? Well, you can see these 2 functions here. I'll explain a little bit more. Embryological precursor of bone. So in your fetus, a fetus does not have a bony skeleton. A fetus has a cartilage skeleton. So before you have bone, you have cartilage. In fact, actually not just in the fetus. You may have heard that like little babies have rubbery bones. I heard that said once. They do. They can bend a little bit. In particular, we're going to talk about bone development later, but there's certain parts like the end of your long bones and your arms and your legs are actually just cartilage when you're first born, and slowly bone replaces that cartilage as you grow up. The other function of cartilage is some support and protection. Now, support would be, maintaining the shape of a structure. It's not, of course, as strong and rigid as bone, but it does provide some support and structure, like think of your nose. Your nose, it's a little flexible, but it is rigid enough that it holds its shape. Protection, there are places like in your ribs, you've got some cartilage in there and some bone. The cartilage also provides some protection for the organs, like your heart and your lungs that are deep to your rib cage. Okay. What is cartilage made of? I changed this slide so you have a slightly different arrangement of all of these words because I realized there was some confusion when I titled it general composition, but this is not technically part of cartilage. So I wanted to make it clear that cartilage, where I saw this, is made of the things underneath general composition. And I just wanted to bring up this again, that cartilage is surrounded with a layer of dense, irregular connective tissue, that, one of the dense tissues. And that layer is called peri, meaning around, chondrium, meaning around cartilage. So again, we're going to see this word chondra or chondri a lot when we talk about cartilage. So whenever you see that, think cartilage. So what's inside of cartilage? Well, just like other connective tissues, there's cells and there's matrix. And the matrix is made of ground, which is sort of a harder gel in cartilage than in the previous connective tissues that we learned. But there is, in fact, a ground substance. And there's fibers. The fibers, depending on the cartilage, can be hard to see. You don't always see them. They're so thin. But there is, in fact, a mix of collagen and elastic fibers. Different amounts and different types of tissue of cartilage, and we'll get to that in a second. Oh, and then I guess I should back up and do the cells. I seem to have ignored them. So the cells, you have 2 cell types. You have chondro cell, meaning cartilage, blasts. Now, hopefully that blast word root is ringing a bell because we already talked about another kind of blast cell. Blast cells build things. So in the case of chondroblasts, they are cartilage builders. So what happens when cartilage is developing is that the chondroblasts will build the matrix, so this part that's not cellular, and the chondroblasts literally just build themselves into a room. It's like if you took a bunch of bricks and you just made a wall around yourself. So you just wall yourself in for life. Though cartilage cells do tend to wall themselves up in little groups called autogenous groups. I'm not going to ask you that on exam. Don't worry about it. But it is nice to have friends if you're going to spend the rest of your life, surrounded by a brick wall and unable to get out. Or maybe not, though. That's a little close for comfort, maybe after a couple of years. Anyway, once they have walled themselves into this little room, we now call these cells chondrocytes. So the site just meaning cell, they're just generally cartilage cells. And at that point, they're not doing lots of protein synthesis because the matrix is already built around them. They do maintain the cartilage a little bit, though, and help try and repair it if it gets damaged, though some of you may already be aware of this. Cartilage does not heal well. If you damage cartilage, it could be damaged for the rest of your life. It just does not heal well. So these cells do have a limited ability to repair cartilage. And the reason for that, actually, the reason that cartilage has such a difficult time repairing is because it's got a pretty limited blood supply or low blood supply. And if you don't have blood, you're not getting, nutrients like amino acids you need to build new proteins. And you also need energy to build things. So you're not getting a lot of glucose or oxygen. So low blood supply means not going to have great repair. Why don't you have a good blood supply? Because you would have to create, if you had a blood supply, you'd have to have all of these, like canals of blood vessels going through the cartilage matrix. That would create, kind of like a Swiss cheese structure, or a lattice work, I guess you could say. Those canals would make the cartilage much weaker. You need this solid matrix in order for cartilage to do its function of support and structure and protection. Okay, so that is the basics of cartilage.